Okay, welcome back everyone. Now in this video we're gonna go over capital costs. Now just to give you a little bit of definition, capital costs are gonna be the costs associated with setting up or building the plant. Okay, and capital costs are a one-time investment. So before we start talking about a chemical plant, before we dive into anything very specific, let's talk about something general. Let's say I want to open a bakery. I want to open a bakery. All right. So now, in order to open a bakery, I need some land, and that I can either purchase or rent. But let's say I have enough money to purchase that land. Let's just suppose I wish I did. And what else do we need? Oh, we're gonna need equipment. Yeah, I'm gonna need my oven, I'm gonna need my refrigerators, and what else? So you get the idea. So equipment is gonna be one of the biggest investments, one of the major investments. You want your oven to work well because that's what's gonna make all your bread or cake, whatever. And in addition to that, let's see, there will be some licensing fees, right? Yeah, I'll have to pay some sort of licensing slash legal fees if I want to open a bakery. Okay. And of course, there are gonna be installation costs. I'll have to get power from the grid. I'll have to make sure everything is all set up and functional. I mean, once you buy the equipment, I also need it delivered and installed. Okay, so all of these costs that we've talked about here are the capital costs of setting up a bakery. Now, let's dive into something a bit more relevant to our field of study. For a chemical plant, what do we need? So, yeah, this is pretty much like a bakery. A chemical plant is a glorified bakery if you think of it, if you so fancy. But yeah, you're gonna need some land, obviously. And for chemical plants, a lot of land is required. If you look at Dow plants or any of the oil and gas plants, they're usually away from cities because you need a good amount of space. So for safety and all that. So yeah, land, we're gonna purchase that. Now for a chemical plant, equipment is the most sensitive capital cost, the most sensitive. I'm just gonna highlight that for you, all right? Because in order to make good products, we need good reactors, we need functioning distillation columns, we need pumps that actually work, and we can't tolerate any faulty equipment. And we have to make sure that our equipments are perfectly sized. We have to make sure that they're perfectly costed, and we have to make sure that they're perfectly installed. So moving on, what else do we need? So yeah, for equipment, you're gonna have all the installation. Um, you're also gonna need piping. So you can say that piping is the equipment cost, but I mean you're still gonna need to hire labor that's gonna fit all your pipes and weld them together and make all your flanges fixed to each other. So yeah. Okay, what else? Now we're also gonna set aside some money, and this amount is gonna be known as working capital. A good rule of business is if you want to do a business of $100, it's good to set aside 20 to $30. So if you're doing a business of $100, it's good to set aside 20 or $30 just to cover unexpected expenses. Now, you can think of this as some form of a contingency, some form of a contingency. So let's say you're, um, well, what example can we think of? Let's say there are some unforeseen costs, like one of your equipments is faulty and you have to purchase a new one, or uh, one of your engineers tells you that you need a spare pump or something like that, and you're like, oh damn, I've spent all my money on the land. I've spent all my money on the land, equipment, and installation, and now you want more money. So it's good to it'll be a good practice to set aside some money. All right, money set aside. And just to make it general, I'm gonna label this as money set aside for operations, for maintaining operations. So, I mean, once you hire workers, you're not gonna have revenue to pay them salary. You're not gonna have revenue to pay electricity. You're not gonna have revenue to cover utility costs. And so those costs are gonna come from working capital. Okay. All right. So, and let's see on the cumulative cash flow diagram that we drew earlier. Our cash flow diagram, if you remember, looked something like this. So we purchase land. Land value is our first big investment, and then the next year we have all the equipments installed and delivered. All right, and then finally we have working capital. We've set it aside so that we can start operation. Okay, so and after that you saw that your plant starts making money and your cash flow looks something like this. So this region right here, if I can just point it out for you. Now this region is where your capital costs are, your main driving costs. Okay, and after this period, so after this period, in your plant is operational, so you're gonna have in this section, since your plant is operational, you're gonna have operating costs. If I let me see if I can highlight this. So in this region, your your expenses are gonna be driven by operating costs, which we're gonna talk about in an upcoming video. Okay, now let's talk about the elements of capital, the elements of our capital costs, starting off with the most important, which is the equipment. So, in order to determine the cost of an equipment, you need to first size the equipment. You need to know what is the volume of your reactor, volume of reactor. You need to know what are the number of stages in your distillation tower. You need to know the power or the head required for your pump, etc., etc. And these are all size parameters. Once you have size parameters, you can look at what's called size cost curves. And if you look at the Cedar textbook, here on page number 453, I have an example. So here they're talking about the cost, the purchase cost of a electric motor. So as you can see, the size factor is the horsepower required for that motor, and this is basically based on a lot of data collected over the cost of motors at different at different powers. All right, and similarly, you can have all sorts of size factors. So for example, for this radial centrifugal pump, the most common type of pump, they're using the flow rate multiplied by the square root of the head required, and based off this parameter, they're going to read off the cost of that particular pump. So that's one way of determining your equipment cost. The other way is using software. So if you've been using Aspen, there's a specific section inside Aspen specifically dedicated to the economics called Aspen Process Economics Analyzer. Okay, APEA, Aspen Process Economic Analyzer, and that gives you both the purchase cost, which is just the cost of the equipment itself, as if it was sitting at the manufacturer's site, and it also gives you the final install cost with the piping and electrical instruments all taken care of. Okay, so that's one way. Another one is cap cost, and cap cost pretty much does the same. And I'm not sure if it gives you the install cost, but it does give you the bare module or purchase costs. Bare module slash purchase costs. Okay, so yeah, that's how our equipment costs are going to be determined. There's one key variable that we've omitted so far in our discussion of the equipment cost. We've been talking about size. Another important variable is time. We've been talking about time value of money in the previous videos. Um, as time goes on, things get more expensive, your purchasing power gets smaller and smaller. So we need some method to account for that. I mean, if I look at a cost index, if I look at a cost curve in 2003, now that cost curve is not valid for 2020, of course, because prices have risen drastically since 2003. But is there some way we can remedy that? If, let's say, if I want to still use this cost curve, is there some correction factor that I can use? Is there some sort of correction factor that will still allow me to use the cost curves from 2003? Turns out there is. It's called the cost index. Okay, and cost index is usually represented by the letter capital I. So here's how cost index is used. So you want to find the cost of a pump in 2020 by reading a cost curve for 2003. Here's what you're going to do. You're going to take the ratio of the cost curves from 2000, the cost index, sorry, from 2003 over 2020, and multiply it from the value that you're getting from your 2003 curve. Okay, so yeah, using this equation, your cost indexes are going to take care of the impact of time on your equipment costs. Now, okay, where do you get these cost indexes? There are some resources for chemical engineers. One of them is, I think it's called Chemical Engineering CEPI. Chemical Engineering, oh, wait a second, CEPCI, Chemical Engineering Plant Cost Index. and another one is Marshall Swift MS cost index. And these should be located in your textbook, or you can search the web, like go to AICHE to get the latest journals that document these cost indexes. Okay. All right. Uh, Size. We've taken care of size, and we've taken care of time. And okay, one more thing going that is worth going over when it comes to finding the equipment cost is the material of construction. Now, usually your base material for most cost curves, the base material that they use is carbon steel. But let's say you want a pump of the same size but in stainless steel or some nickel alloy, something like that. Usually, carbon steel does not perform very well when you're handling corrosive or very high temperature substances, so you have to switch to stronger and more thermally resistant alloys. And this can be taken care of very easily. So you can use what's known as the material factor. And once again, these are tabulated in various textbooks, and it's better to use the latest edition to get the most accurate predictions. So, yeah, cost of a steel pump would just be equal to the material factor times the cost of pump in the base material, which is usually carbon steel. Alright, so we've gone over the equipment cost extensively. And alright, so if you know the size of your equipment, you know you want to take care of the time dependence of your costs, and we know how to take care of uh, the impact of using different materials on our costs. Now, before I finish off with equipment costs, I'm just gonna leave you with a shortcut method. Now, let's say you know the cost of an equipment at a certain capacity, and now you want to estimate the cost at a new capacity. Now, this relationship, there is actually a relationship that can be used called the economy of scales. So that basically would be C1 over C2 equals Q2. Oh, hold on, my bad. So it's C2 equals C1 multiplied by Q2 over Q1 raised to power some exponent. And now M can range between 0.3 to as high as 0.84. Usually an average of 0.7 is used for equipments. Sorry, 0.6 is used for equipments. And I believe 0.7 is used for plants, but we'll get to plants in the next video. So, okay. Let's see if there's anything else that I want to go over. Now, in the Cedar textbook, there's a lot of detail which is very helpful when you're actually doing costing for your capstone. But then again, it's a lot of material, so it's usually best on a per need basis all of this information. And whether you're actually going to use all of this information or not is still debatable. Okay. So that'll be it for this video. I'll cover the next elements, mainly the land installation and working capital, in a second part of this video.